In the previous video, we have finished implementing the binary space partitioning algorithm into our procedural generation algorithms. Now, I would like to create a room first dungeon generator. So let's create a new script inside the scripts folder, and do make sure that you save the procedural generation algorithms script. So right click, create a new C# script, and let's call it room first dungeon generator. Okay, let's open the script up in Visual Studio. Great. Again, we will want to inherit from our abstract dungeon generator, or rather, since we will want to have an option to generate our rooms using the random walk, we are going to use again the simple, instead of monobehavior, the simple random walk dungeon generator as the base class for our room first dungeon generator. Let's delete the start and update methods, and we are going to need to have some parameters for our generation. So let's create private int, and let's call them min room width. Let's set it to be, for example, 4, comma, and let's create min room height equals 4 for now. And let's add serialized field attribute to those so that we can set them through the inspector. Next, we will want to have a parameters for the cave size, or rather the dungeon size. So this is the big area that we want to split into small rooms. So let's create private int, and we are going to call maybe dungeon width and set it to 20, and dungeon height, and let's set it to 20 as well. And again, let's add serialized field attribute so that we can see those parameters through the and set them through the inspector. Now, before we create our rooms, we will want to have a way to offset them from the bounds of our rooms, since if we create the rooms as we have the rooms created by the binary space partitioning algorithm, they will be connected through the floors of those rooms. So to prevent this, we are going to decrease the size of our extracted rooms by an offset. So let's create a private int, let's call it offset, and let's set it to be 1. We are going to add to it serialized field attribute as well as a range attribute, and let's set the range from, for example, 0 to 10. So this will ensure that we have walls dividing our rooms. In addition to this, we are going to have a private bool flag, and let's maybe call it random rooms or random walk rooms. Let's set it to be false, and this will be responsible for checking if we want to use random walk algorithm to create our rooms, or do we want to generate the square rooms, so use the full bounding box of our rooms to generate floors everywhere. And last step that we will need to do is reuse the simple random walk parameters that we have exposed. If we right click on the simple random walk dungeon generator, we have those simple random walk SO parameters exposed as the protected value, so we will use this to generate our random walk rooms if we need to. But for now, let's focus on actually creating our room spaces. So let's add to this bool flag serialized field so we can set it through the inspector, and this should be it. What we will need to do is to override our run procedural generation method. So let's type override, and we should have run procedural generation, and we do not want to use the same method as we have in the simple random walk dungeon generator. Instead, let's create a method called create rooms, and let's alt enter on it and generate it here. We are going to simply call our binary space partitioning algorithm, so var room list equals our procedural generation algorithms dot binary space partitioning, and we are going to pass it a new bounding box or new bounds int. So let's type new bounds int, and again we are going to have to pass the start point as the first point of our bounding box. So let's type in the parentheses vector3int to cast it to vector3int, and let's type start position that we have defined in our abstract dungeon generator. And next we want to create a vector that represents the size of our dungeon that we want to split into rooms. So new vector3int, and we have defined our dungeon width and dungeon height. So let's type dungeon width, dungeon height, and 0 for the z value, since this is a 2D space. And this should be it, but we also need to pass the minimum width and height of our rooms. So let's type min room width and min room height after we define the bounds int for our area to split. And now we should be good to go. So now we have run the binary space partitioning, and it has created for us our rooms bounding boxes. So we are going to create a hash set of vector2int. Again, let's call it floor equals new hash set. And we are going to call our floor equals create simple rooms. We are going to modify this code when we implement the random walk generation. For now, let's pass to it our room list, or we can rename it to rooms list. Okay. And we do not have this method, so Alt Enter and generate it. And at the end, of course, after we have this list of floor positions, we can call our tilemap visualizer.paint floor tiles and pass it our floor. And we can call our wall generator.create walls, pass to it our floor hash set, and pass to it our tilemap visualizer. Okay, so last thing that we will need to do for now is to create this create simple rooms method. So we have our list of bounds int, and this is rooms list. So all we need to do is create a new hash set of vector2ints. Let's call it floor equals new hash set, and we are going to loop for each our var room in room list. So we are looping through each bounds int, and here we are going to simply call for loop and for row equals, and we want to use our offset as the first point, so offset will be 1. Row is less than length, so this will be room dot size dot x, so this is width, minus offset. So actually the row is for the y value, so I'm going to Ctrl RR and rename it to col. This will be column. So the columns are on x-axis, and the rows will be on y-axis. So again, another for loop. So for tab int row, and row is equal to offset, and row is less than room dot size dot y minus offset, so that we can apply the offset to our room size. Now all we need to do is to calculate vector2int position equals a vector2int, we are going to cast it a room dot min, since this is the minimum point, so the bottom left corner, plus our new vector2int, and we are going to pass column as x value, row as y value, and since we do not have z value, we are going to create vector2int. Great. And after this, we are going to add this point to our floor hash set, add our position. So now we have basically created for each point in our bounds int a floor position. We have added those positions to our floor hash set, and we have looped through each room. So now our hash set contains all the floors for all the rooms. Now, of course, if you would like to decorate the rooms procedurally, you would have to save each floor room in a separate hash set or a separate object, and then process it further. Since we are only interested in creating floors, we are going to return our floor hash set. And this should be it. So now we should be able to go back to Unity and to create the rooms first. So let's save it. Let's go back to Unity. Great. Now we will create a new object in the hierarchy. So right click in the hierarchy, create, and let's call it rooms first dungeon generator. Okay. Let's add to it room first dungeon generator script. We need to select the tilemap visualizer. Start point will be 0, 0. Random walk parameters. We can select island for now, but it doesn't really work right now. The min room width and height will be 4. Well, maybe for the better result, let's set it to be 10, as I see in my previous project that I have set it to this value. And width, let's set it to be 70 and height 70. And since the random walk rooms doesn't do anything, we are not going to set it. Let's generate it. And you can see that our rooms were generated. And as you can see, if we decrease the offset to 0 and generate those, we have a small bug in our procedural generation algorithms. So let's go back to our scripts folder and let's reopen procedural generation algorithms script. Great. The bug is in the split horizontally and split vertically method. In the split vertically, when we set the room first, we set the min position correctly, but the size is set incorrectly. We do not want the room min Y, we want to set room size Y and room size Z. Okay. And for the horizontal split or split horizontally method, it all looks pretty good. So let's save it. Let's go back to Unity. Great. Let's select our room first generator and let's generate our dungeon. And you can see that the generated dungeon behaves much better. And again, if we set the offset to be 0, we can see that those rooms get connected because we are using the full size of our rooms. And since there is no tile in the middle, this connects those rooms into a big dungeon or big connected rooms. So we need to set our offset to something like 1 or 2, and then we can create separate rooms. And you can play around with this setting. Now in the next video, I would like to make sure that we can connect those rooms using corridors so that the rooms are connected, as well as to use this random walk rooms boolean flag so that we can use random walk algorithm to create those rooms instead of always creating those rectangular shaped rooms. Now if you are enjoying this tutorial, please leave a like, leave a comment, it would help me a lot. See you in the next video.